Okay, ladies and gentlemen, today we are going to look at chemical kinetics. So now we are starting with the kinetics. What is kinetics? If we said kinetics, it means how fast does a reaction proceed. You know that generally when we have a reaction, that is a chemical reaction where reactants are converted to products. So the time it takes for the reaction to take place, that is the time it takes for the reactant to be fully converted to product, is what we call kinetics. That is how fast that reaction is taking place. Is it in 2 minutes? Is it in 3 minutes or in 5 minutes? That is what we mean by kinetics. Then thermodynamics. So a thermodynamics is the use of some certain chemical parameters to know whether the reaction will take place. So like gives free energy, enthalpy, entropy. You know that generally, like for the gives free energy, if gives free energy is negative, it means that the reaction is spontaneous, meaning that the reaction can take place. Okay. Thermodynamics is is to know whether the reaction is taking place or not. Then we have some important factors that affect the rates of the reaction. So these are the factors that affect the rate of the reactions. Their presence or their absence, or maybe the alteration or the increase of one of the factors or decrease may increase the rates of the reaction. So the rate here means also the time for the reaction to take place. So we have some factors that we are going to consider. And we also have reaction speed. Reaction speed measured by the change in the concentration with time. So you know that if we are having reaction, the reactions are usually measured, or the rate of the reactions are usually measured by the decrease in the concentration of the reactant with time, or increase in the reaction with time. Sorry, increase in the concentration of the product with time. So reaction speed can be measured by either decrease in the concentration of the reactant or increase in the product's concentration with time. You know that generally if we have reactions to take place, like for example, if we have A as a reactant to produce B, so what we need to understand before this A is converted to B, of course, the concentration of A must be decreased and the concentration of B must be increased. So the reaction speed can be measured by decrease in the concentration of A with time, or increase in the concentration of B with time. So it's either the decrease in concentration of A with time or increase in the concentration of B with time. So that is why we said reaction speed are measured by the change in the concentration with time. So the change in the concentration can be either in it can be measured, can either be increase in the concentration of the product or decrease in the concentration of A. That is what we mean by the reaction speeds. Okay, then the next thing under this, we have the factors. So we are now going to look at them one after the other. We have reactant concentration, we have temperature, we have action of the catalyst, surface area, pressure of gaseous reactant or products, and then we also, so these are the 5 major factors that affect the rates of the reaction. Like for example, now let me just look at these factors briefly. The increase in the concentration of the reactant can increase can increase the rates of the reaction. Also, increase in temperature can also increase the rate of the reaction. While also applying the catalyst, we know that catalysts are substances that speed the rate of the chemical reaction. So therefore, if you have a reaction and you use catalyst in that reaction, it means that the rate of that reaction will increase. When you say the rate of the reaction will increase, it means that the reaction will take lower time to produce a product. Maybe, for example, if the reaction is taking place without the catalyst, maybe in 30 minutes, but in the presence of the catalyst, the reaction will take place in less than that 30 minutes, maybe in 10 minutes or 15 minutes. That is what we mean by the rate of the reaction. We also have increase. We also have surface area. So the presence of the increase in a surface area of the reactant molecules also increases the rate of the reaction. Then we also have the pressure of gaseous reactant or product. The effect of pressure is only applied in the reaction where all the reactant and the product are gaseous. And generally, increase in pressure also leads to increase in the rate of the reaction. So this is briefly on the introduction of the chemical kinetics.